Okay, in this problem, we have a table that shows the quantity of lobster that is sold or demanded to customers during 8 randomly selected days of the current year. You have the price of the lobster. That's how much it charges per lobster on a given day. So some days the lobster price is low, some days the lobster price is high. And when you go into most seafood restaurants, you'll see that lobster, if it's on the menu, will be like the day's market price. So all the other prices are printed, but in a lot of American seafood restaurants, maybe lobster, it just says the market price. And then you have the average customer income of, so on these randomly selected days, maybe you do a survey and people fill in their incomes, right? We're gonna use this data estimated demand curve. So the first thing we want to do is we're gonna copy the data. I'm gonna start with month, then we go down to the C and compute. We're gonna copy that and paste that into Excel. And this Excel sheet, if you notice, I've saved it as IIL6, and we're in sheet 1. So question 1 of interactive individualized. Oh, this should be IIL6. IIL6. Okay. All right. And then we want to get the mean of quantity of lobster sold, mean price of lobster, and the mean average customer income. So what I'll do down here is I'll put in means, a row called means. So I'm in row 11, and I'm gonna do equal average. And we're gonna get the average quantity of lobster sold. So we got the average quantity of lobster sold, we got the average lobster price, and we got the average customer income. So we also need to make that 2 decimal places, right? So I just highlighted the numbers, went up the number in the home tab, and then click the number of decimal places. And we can type them into here, right? So my average quantity of lobster sold is 117. My average price of lobster sold is 37.24. And my average customer income is $6,341.75. Okay, did you hit the green check marks? I'm gonna format this too. I'll format this. I'll go up here to alignment and word wrap. And then I'll widen the columns. There you go. Hey, Matthew.
Hey, how's it going?
Good. We're working on in-class lecture 6. So yeah, we're working on this one. Question 1.
Okay, I'm loading it in right now.
Okay, you got Excel at home, right?
I have Google Sheets.
Ooh, that's gonna be kind of hard. Let me help you do this. I'm gonna put this on pause.
Okay.
I'm gonna pause the recording. Now we've got this data here, right? We're gonna use Excel to perform a multiple regression. And to do that, you'll have the data. You have the data tab here, right, Emmanuel? Yeah, your data tab.
Yeah.
And you got your data analysis tool, right?
Give me one second. I have to make my team bigger. I'm going data, right? Yeah,
You got the data analysis tool right there on the data tab.
yeah.
All right, so when you click the data analysis tool, you should get a little box like this, right?
No, here I can see. I just see analyze tool.
You got data analysis tools.
Yeah,
You see
and
it?
then there I see analysis toolpath and solver ads.
You want to go down to regression. So you got it on regression.
Let me show you my screen.
Okay, let me stop my share.
No, you don't have to stop. I can.
Are you going to share your screen?
Yeah, let me see. Can you see?
You can flip the camera so I can, yeah, there you go. All right. Oh, you need to put that in. Yeah, check mark analysis tool pack. And you can do
This one?
solver add-in too. You can click the solver add-in and then hit OK. Yeah. And then it should show up in your ribbon, right? Yeah, and you want to find regression. Click on regression. And then click OK. All right, good. All right, sweet. Okay, so yours looks a little different because it's a Mac, right? So you click
Yeah.
regression, you click OK, and you got the regression menu, right? The
Yeah.
first thing we need to do is we need to load the Y range. And if you come down here, you notice that price and income are in this table. So that means we're going to predict quantity demanded. Okay. So in the Y range, you want to, with the blinking right here, see it's blinking.
Mhm.
You want to click and hold down your mouse button from B1 down to B9. Right. So B1 to B9.
Yeah.
Okay.
Mhm.
And then your X input range, your input X range is from C1, holding down your left mouse button to your, so from C1 down to D9. And you got the dashed line around both columns, right? So, yeah.
Mhm. Mhm.
So you got your data loaded, right? Now, because you're
Yeah.
including row 1 that has labels, you want to check mark labels. You want to check the labels. All right.
Yeah.
And then I want to put the output in the same worksheet. So I'm going to click output range. Right, I'm clicking output range. I'm going to click in this box so it's blinking. All right.
Mhm.
The output, the box next to output range. And then I'm going to type A14. I'm going to put the output down here in A14. All right.
Mhm.
Then we'll hit OK. All right. So now we have our output, right?
Yeah.
What I'm going to do next is I'm going to widen column A so I can see the words. Right. There we go. I widen column A. And then I'm going to hold down my control button. Or sorry, I'm going to click over here somewhere. I'm going to click on this number here, the multiple R. I'm going to hold down my control button. And I'm going to get all the numbers with decimal places. See? I'm getting all the numbers with decimal places. I'm just holding down my control button. Or it's probably your command button, right?
Yeah.
All right, I got all the numbers I want to round to how many decimal places? Two decimal places. Five decimals.
Why?
Right? Five
It's not
decimals.
working.
So I'm going to come up here to home. I'm going to click on the number, right? And I'm going to add or reduce the number of decimal
Yeah,
places to 5.
that's what I do, but I don't know why.
So I
Not sure.
got 5 decimal places everywhere, right?
Yeah.
Right. I
Let
got
me
5
see.
decimal places. I didn't change the decimal places of observations, degrees of freedom for regression, degrees of freedom for residual, and degrees of freedom for total. I didn't change those decimal places. I just changed all the other values, all the other decimal places. Oh, you showing me the screen?
Yeah, can you see?
Yeah.
I have everything. Then when I come here,
Yeah, right there. You want 5 decimal places, right? So
yeah,
looks
but
like you got,
it's not,
it looks like you got
it's not
6. So you need
moving.
to back it off a little bit. Back it down. Yeah. Is it changing
It's
the
not
number of decimal places?
no,
Click on general and then number. Click number below it. And then see if that works.
no.
Okay, I think what you did is you highlighted too many of them. You want to highlight just the numbers.
Oh, it's okay.
Yeah. So on your do this. So click on multiple R like this. Don't double click it, right? Just single click it.
I
Hold
just
down
try
your
to do
command.
one.
Yeah, hold on your command button and
Yeah.
then click the numbers below it like that. Are you highlighting them one by one?
Mm-hmm.
Highlight the ones below SS, MS, F, and significance F, right? One at a time.
Okay.
Then do the coefficients, the standard errors, the t-stats, and the p-values. Are just the numbers highlighted?
Mm-hmm.
Now you can go up to home, click on number, and you change the number of decimal places.
Yeah, it's working now.
Did you get 5?
It's 5 or 4.
5. Yeah, 5.
It's okay.
So you got 5
I
decimal
have it.
places?
Yeah.
You good? Okay. All right. Now what you're going to do is under lower 95. See what I'm doing here on lower 95 see what I'm doing below the table? I highlight these cells below lower 95, upper 95, lower 95, upper 95. You see that?
Yeah.
What I'm going to do is I'm going to pull this up because I don't need this stuff. Right? I don't need that stuff. I just need the coefficient, standard error, t-stat, p-value.
Okay.
Okay.
Yeah, it's okay.
You got it?
Yeah.
All right. I'm going to widen that out a little bit. Now notice over here in the ANOVA table in my open math, it says F here, right? And it has a P here, right? In Excel, they do F and then significance F. Change significance F to p-value. This is the p-value of the F statistic, right? So I got F and p-value, right? Also, you can change this to F stat, F hyphen stat. It's a test statistic. F stat is a test statistic. So to the right of MS, replace F with F stat and significance F with p-value. I don't like significance F. I prefer p-value because it's a probability value. This is the probability of being bigger than that number in an F distribution with 2 degrees of freedom in the numerator and 5 numerator degrees of freedom, right? So this is the probability of being bigger than that. Okay, you got that? And then where it says residual, change it to error. So these are the changes here, right?
Mm-hmm.
Most statistical packages call it error instead of residual. They call it F stat instead of just F, and they call it a p-value instead of significance F. So you want to make these 3 changes to it that I put in red. All right.
Yeah.
Now it's just a matter of typing the numbers in, right? Now it's just a matter of typing the numbers in. Okay, so here's this right here, SS is a sum of squares. I don't know why Excel does this, but it puts, usually a statistical package will put the SS's right here and the degrees of freedom here. I don't know why it does this. It kind of does it backwards. Excel is a great tool, but there's a lot of things I wish it did differently, right? So this is the sum of squares. So what I'm going to do is I'm going to copy my sum of squares due to regression and paste it right there. Sum of squares due to regression. See that?
Yeah.
I'm going to copy the sum of squares due to error and put it here. Sum of squares due to error. I'm going to grab the sum of squares total and paste it here. Now I'm going to do the degrees. I'm going to do the degrees of freedom. I got 2 degrees of freedom, 5 degrees of freedom, and 7 degrees of freedom. Okay.
Yep.
Now, the 2 degrees of freedom for the regression, that's because we got 2 variables, right? Our X variables are these 2 things. There's 2 of them, right? This is our Y variable. This is the thing we want to predict. So this is the thing we're trying to predict here. What happened? The purple thing is, this is what we're trying to predict. We're trying to predict how much quantity of lobsters our customers will demand, given the customer income and the lobster price, right? So this is what we're looking to predict.
Wow. I don't know why.
What's going on?
I don't know what I pressed back. Something is wrong.
Something's wrong?
Yeah.
Which one's
I'm
wrong?
talking about the degree of freedom,
Yeah.
the MS.
Degrees of freedom?
Yeah.
Well, your degrees of freedom should be 2, 5, and 7, right? 2, 5, and 7?
Okay. Yeah. I put the wrong
Remember,
kind of,
Excel does it backwards. You got to flip these 2 columns.
yeah.
Okay, you got to flip
I
those 2
understand.
columns.
It's okay now.
Yeah. Then we're going to copy the mean square due to error. I mean regression.
Yeah. It's okay now.
And then the mean square due to error. The F statistic. And the p-value. Okay. Now, the thing is, the mean square due to regression manual is just this number divided by that number. That's all that is. So if I were to type over the top of MS regression, if I type in equal, and then I click on this cell, if I type in C25, whoops. So I got C25 here divided by B25. See, I'm dividing this box here by that box.
Mm-hmm.
I get the mean square due to error, right?
Okay.
Yeah, and then if I do the same thing here, C26, I'm in row 26, right?
Mm-hmm.
Divided by B26. I think my batteries, my keyboard are going dead. If I divide those 2, I get the mean square due to error. And then the F-stat ends up being the ratio of these 2 measures of variance. The F-stat ends up being a ratio of this variance divided by that variance. That's what the F-stat is, right?
Okay.
D25 divided by D26. So I'm taking the ratio of these 2, right?
Mm-hmm.
Yeah. Down here in the coefficient part, these are the estimated coefficients of a line, right? right?
Mm-hmm.
These are the estimate. These are this is a line, a linear equation that we've estimated. These are the standard errors that correspond to them. The test statistics are just the ratio of these two. So this divided by 17 is 9.22. This divided by 0.239 is negative 8.12. This divided by that is 2.17. So you take the ratios of these two numbers, you get that. You take the ratio of these two numbers, you get the t-stat. You get the ratio of these two numbers, you get that t-stat. These are test statistics. These are standardized values of this, right? If we want to know if that's 0, then this has to be significantly different than 0, right? This has to be way below 0 or way above 0, right?
Mm-hmm.
And we'll get to that in a second, right? So I'm just explaining to you how these numbers come about, right? These numbers are just ratios of these pairs, right? That's what these numbers are. And these are the probability values. These are two-tail probability values. So the probability of being bigger than this is about 0.000125. The probability of being smaller than the negative version of that is 0.000125, right? When you add those two together, you get the 0.00025, right? So these are two-tail probability values. We're doing a two-tailed test on this and on that. We want to test if this is equal to 0, right? That's a two-tailed test. We want to test if this is equal to 0. That's a two-tailed test, right? And these are two-tailed. These are probability values of being less than negative 8.2588 and or being greater than positive 812588. This right here is the probability of being less than a negative of that value or being greater than the positive of that value. So these are two-tailed probability values. This is the one-tail probability. Right? This is just the probability of being greater than that number, right? I can show you right here how that works. So I got f dot dist dot rt. I got the f statistic. I got the numerator degrees of freedom, and I got the denominator degrees of freedom. And notice that it equals that, right?
Mm-hmm.
So this is an upper tail probability. It's the upper tail, it's the probability of being greater than this number. Yeah, it's probability of being greater than this number. So that's the F statistic, that's the numerator degrees of freedom, and this is the denominator degrees of freedom. So this is an upper tail probability right there. Right?
Oh.
All right, so we got to type these numbers in, right?
Mm-hmm.
We got to copy these numbers in. These two numbers, the ratio of these two numbers is the t-stat. The probability of being greater than a positive 9.22 or being less, whoops. The probability of being greater than this number or being less than a negative of that number is this p-value. Okay, so we just continue doing this. So here's our coefficient. This is our standard error. The ratio of those two numbers is a negative 8.12588. And then the probability of being less than this negative number or being greater than a positive of that number is that value. Then we got the coefficient here. We got a standard error here. The ratio of those two numbers is 2.17081. The probability of being greater, than that or less than a negative of that is that value. We hit enter, we got green check marks, right? Oh, wait a minute, what
Mhm.
happened? Why are my numbers off? Do I need to change it to 4 decimal places? That's weird. Huh. Do you get correct answers?
I'm on that. No,
All right,
I
let me
have
see.
some correct, and then the
Maybe I
p-value.
changed. Maybe I changed the decimal places. Okay, I guess I'm doing 3 decimal places.
Yeah, and also my income for the standard, the last one. Yeah, that one also come.
Yeah, change them to 3 decimal places.
Okay.
Looks like 3 decimal places works. Yeah, that's weird. Let me go up and modify. I'm going to put it on pause real quick. I'm going to modify the instructions. Let me check to see if this works. Yeah, I guess I changed it to 3 decimal places. Yeah, I changed it to 3 decimal places because there's too many. Yeah, 3 decimal places. It's kind of funny, my open math. It's great, but it counts them wrong. Yeah, just making sure that 3 decimal places work. All right, I'm going to put this on
Okay.
pause and I'll go fix it. Okay, so yeah, 3 decimal places. Yep.
I don't know why it come wrong. Give me a second. My standard error for the income.
Yeah, which one? Standard
The
error
standard error, the income.
for income.
Yeah.
See,
Okay.
I changed in your Excel, Emmanuel.
Yeah. Yeah.
Round it. Use Excel to round it by
Yeah. It's
changing the
okay
number of
now.
decimal places. Yeah. See, I'm using Excel to round it for me, and then type in the number that Excel gets when it rounds it for you, because you might have done a rounding error in your head. What do you have for the customer income standard error in your Excel spreadsheet? What do you have for it in your Excel spreadsheet?
For the standard error,
Yeah,
yeah, I have 0.002.
that's what you don't see something look like this, right? I mean, you're only seeing 3 decimal places.
Yeah. Yeah. I already do that. It's okay now.
Okay, and this is not working over here.
Yeah.
Okay, let me find out what's going on. It says it's right. The answer
Yeah,
key
it's
says
right.
it's right. Oh, what was your question then?
No, it's okay now. I have to
Okay.
click
Oh, okay. All
on
right.
create
Cool. All right.
decimal before.
Okay. I thought you had an issue. So,
No, it's okay.
all right, cool. Now in month 3, a residual of blank implies sales. So in month 3 up here, we got month 3 right here.
Yeah.
So in month 3, let's highlight month 3. I'm gonna make it bold and red. There's month 3, right?
Mm-hmm.
So in month 3, we got to calculate the residual. So how do we calculate the residual here? The way you calculate the residual is you take, so are you in E4 right now?
Yeah.
So we're going to calculate the residual. So we're going to type equal,
Equal. Mm-hmm.
and then we're going to go down to the intercept. Okay, right there, we're going to go to the intercept. So I did equal B30 because my intercept's in B30.
Yeah, mine too.
Okay, all right. So we got the intercept, right?
Mm-hmm.
And then we go back up here and we're going to do equal plus. So I got equal B30 plus. I'm going to click on the lobster price. See, I clicked on the lobster price.
Yeah.
All right, I'm going to hit times. I'm going to multiply the lobster price, which in my case is 39.30. I'm going to multiply the lobster price by the slope of lobster price. See that?
Yeah.
Okay, and then I'm going to hit plus. I'm going to click on the customer income in month 30 or month 3. See that?
Yeah.
D4. So I got plus D4. And then I'm going to do times after D4, right? And then I'm going to come down here and get the slope of customer income.
Okay.
All right. So we got the
Mm-hmm.
intercept plus the price times the lobster price slope plus the customer income times the customer income slope, right? And we should get something that's pretty close to our sales. This is our predicted value. We predict how many lobsters will be sold given that price. I'm predicting 119.98. Is that pretty close to what we observe?
Yeah. Mine is 154.
What's your quantity demanded? What you observed? Mine's 121. See, my observed is 121. My predicted is 119.98.
Mine is 154.
And that's your quantity demanded in column B?
Yeah.
And then in column E, what's your predicted value?
Is also 154.
Point?
167.
So it's not exact, right?
Yeah.
The probability that this number and this number equal, the probability that these two numbers equal is 0, right? There's going to be a difference, right? Because this number is what we observe. It takes on one value. But this number can theoretically take on many different values, right? Now, the difference is the residual or the error. So we got the predicted value, or sorry, we got the observed value minus the predicted value. That's the error. So my model is doing a pretty good job of predicting reality, right? You see that?
Yeah.
It's just the difference. It's B4 minus E4. That's the error in the model. Now you see this with the draft. The NFL draft, Tom Brady, the greatest of all time in the NFL. They call him the GOAT, greatest of all time. GOAT. He was a 6th round draft choice, which means NFL teams didn't expect him to do much, right? So his predicted value was 6th round quarterback, an average quarterback.
But mine is negative.
Yeah, because your predicted value is bigger than your observed value, right?
Yeah.
Sometimes your prediction is below what it should be, and sometimes your predicted value is greater than what it should be, right? We're predicting,
Okay.
right? We're making
Mhm.
predictions. And when you make predictions, you make errors, right? When you make
Mhm.
predictions, you make errors. So my residual is 102, right? A residual of 1.02 implies that sales, my sales, the ones I observed, 121, is what? My sales exceeded expectations, right? When the price is
Mhm.
39.30 and the customer income is 80.52, I observed 121, that exceeded what I had predicted, right? You're going to say
Mhm.
what? Instead, you're going to say
Below.
below, right?
Mhm. But I
Okay.
don't know why it's coming error.
Where's the error?
Uh, for the residual.
Oh, try 3 decimal places.
Okay.
Yeah, try 3 decimal places. Whoop.
My good now.
Is it good?
Yeah.
Yeah. I'll try 3 decimal places. Yeah, 3 decimal places worked, right? So you can see that predicted values aren't necessarily going to, they're probably not going to equal, very likely that they equal what we observe, right? In the NFL draft, Tom Brady was the 6th round draft choice. He ended up being the greatest of all time. So the draft that year says he's going to be an average quarterback for the year he was drafted in. But he ended up being the best quarterback in the history of the NFL, right? You see that?
Yeah.
Okay, so moving on. From the regression statistics table in the Excel output, use the answer the following. The coefficient of determination equals what? The coefficient of determination is your R squared. See my R square here?
Mhm.
And it wants 3 decimal places. So I'm going to change these to 3 decimal places. So R square is your coefficient of determination, right? And it's pretty close to 1, right? That
Yeah.
suggests the model does a pretty good job. I just noticed my shirt is probably on backwards. I put it on last night in the dark of night. Again, we don't have plumbing, so I can't take a shower. And I didn't want to
Yeah.
wake anybody up, so I put my shirt on backwards.
Wow.
I just noticed that. And I didn't take a shower this morning because of the plumbing, right?
Yeah.
Okay. That's our coefficient of determination. The thing that we estimate in multiple regression, though, is our adjusted R squared. So I want to copy the adjusted R squared. It's a little lower, isn't it? Or it's a little different. It's a little
Yeah.
higher than the R square. Okay. In simple regression, you interpret the coefficient of determination. In multiple regression, like we're doing today, we interpret the adjusted R square or the adjusted coefficient of determination. All right, so what we're going to say here is it implies what? If I convert this to a percentage, what do I got?
9.
93.4, right?
Yeah, 93.4.
If I convert that to a percentage, 93.4.
Mm-hmm.
So this adjusted R square implies that 93.4% of the variation in the thing that we predicted. What was the thing that we predicted? What were we predicting? We have the 2 X variables, right? We're
Mm-hmm.
using lobster price and customer income to predict what?
The demand.
Demand, right? That's what we did here, right? We took the intercept, we took the lobster price of 39.30, multiplied that by the slope, took the customer income, multiplied that by its slope, and we came up with a predicted value. This is the predicted value of quantity demanded, right? So we're predicting quantity demanded, right? Quantity of lobster sold. We want to. Why do we want to predict the quantity of lobster sold? Well, if we're a restaurant and we buy too much lobster, what's going to happen? If we buy too much lobster and the price is really high, what's going to end up happening? Are people going to buy it if the price is high and we bought too much?
No.
They're not going to buy it. So what are you going to do with all that fresh lobster that you just shipped in from Maine?
Mm-hmm.
You got to turn it into lobster bisque, and you can't sell it as high a price as fresh lobster, right?
Yeah.
Or you put it in a lobster salad and you make a lobster salad sandwich. So when a restaurant has too much of something, that's the next day they'll have a special on lobster, right? So whenever you go to a restaurant and they're having a special, it's probably because they bought too much of it the previous day and they got to get rid of it. At Wendy's, do you know why they serve chili at Wendy's? Matthew or Emmanuel, you know why they sell chili at Wendy's?
No.
What's in the chili that's also in a hamburger? In a hamburger sandwich. What's common to chili and hamburgers? Ground beef, right? So Wendy's, when it first started, its whole thing was we have fresh beef, right? If they buy too much fresh beef that day and they don't sell it, what are they going to do with that fresh beef? They can't freeze it because their whole business model is fresh beef. They cook that beef and they put it in the chili. See what I'm doing? They're doing, right?
Mm-hmm.
If you buy too much lobster and you don't sell it that night because the price is too high, the next day you got to make lobster rolls. You have to make lobster salad. You have to make lobster bisque. Or you have a lobster crab salad or something, right? Or you just have a lobster special. You got to get rid of that lobster. So it's not as fresh the next day, so you can't charge as high a price. So restaurant specials come from having too much quantity on hand. And that's why you want to do stuff like this, right? You want to sell your lobster at full price. You don't want to sell your lobster at a discount, right? Because it costs you a lot of money to get to your store. You don't want to sell it in a chili. You don't want to sell it in a soup like lobster bisque. You don't want to sell it on a sandwich like a lobster salad sandwich. You want to sell it fresh, right? So you want to run regression so you can get a pretty good idea of how much you're going to sell that day, right? So you have to collect data, you run it through a regression program, and you get an idea of how much lobster you need to get at the current market prices, right?
Yeah.
I suspect the markup on most restaurant items, above cost. So if they buy a lobster for like $20 a pound, they probably sell it for $30 a pound. I'm just guessing. There's probably like a substantial markup on it, right? So if you're buying lobster for $40 and you're going to sell it for $60, right? You don't want to buy too much of it because the price is too high. So that's why you want to do this kind of work, right? Do you see?
Mm-hmm.
This is a big part of operations management, right? You don't want to buy too much of your raw material, right? And then, so 93.4% of the variation in what we're predicting, in this case, quantity of lobster sold, is explained by average customer income and the price of lobster, right? Got it? Now we're going to use the p-values. We're going to test these hypotheses. This right here, do we know beta? Can we know the true slope of the relationship between price and quantity holding income constant? Can we know that true value? We can't. Greek parameters like beta, those are things that only God knows, right? We're not God.
Mm-hmm.
But we can estimate them, right?
Yeah.
So we can't know if this true beta is 0. We have an idea that it's, probably negative, right? We have an idea that it's negative. Yeah. We can estimate it, and that's what we've done. We've estimated, right? So this hypothesis here When we're testing that hypothesis here, we're looking at the p-value of lobster price, right? We're looking at this. You see that?
Yeah.
And our significance level is 1%. Most businesses use 5% significance, right? I would say that the rule of thumb in politics and business is 5%, right? But this particular business, for some reason, is choosing 1%. What is your business choosing? Is your significance 1%? Right here?
No, mine is 10.
Yours is 10. Okay. So my p-value is small, smaller than 1%. What does that mean? This number is big in absolute value. So when the t-stat is big, ignoring the negative sign, when it's big, that means it's way out in the tail, right? So the likelihood of that being a result of just randomness, random stuff happening, right, is very tiny, which means we're going to conclude that this coefficient is probably pretty close to, it's negative, and we're going to conclude that it's equal to a negative 1.948. Why? Because it's really significant. The smaller the p-value, the more significant that coefficient is, right? We're actually testing whether this is equal to 0, right? So the difference between this negative number and 0, that's a significant difference. So we're saying that this number right here, the coefficient, is significantly different than 0 because the p-value is so close to 0, right? So we're concluding that this is not 0. We're saying it's negative 1.948, right? So are we rejecting or accepting or failing to reject that hypothesis? Which one?
It's supposed to be rejected.
We're going to reject it, right? What's your p-value?
Yeah.
What's your p-value in your table for lobster price?
0.01.
Your p-value for
0.001.
lobster, yeah, 0.0001.
Yeah.
And your significance level is 0.1, right? Because it's 10%.
Yeah.
So your t-stat is pretty big, right? What's your t-stat equal
Yeah.
to? What is your t-stat equal to?
Is negative 6.34.
Negative 3. So yeah, what you're saying is that your coefficient, the difference between your coefficient and 0 is significant. Mine is really significant, right? Because my p-value is 0.000, right? So I have a lot, that my coefficient is really significant, right? And then your customer income is what? My p-value is 0.082. My p-value is bigger than my significance level. So that says this t-stat is small. See that? My t-stat is small, quote unquote small, because my p-value is bigger than my significance level. My significance level is 1%. My p-value is 8%, right? So my t-stat is small. So the difference between my customer income and 0 is insignificant. So my customer income coefficient, the difference between it and 0 is insignificant. So I'm gonna not reject my income hypothesis. All right, I have to go back and explain this.
Okay.
All right. So we have, I forgot where in summary, or not in summary. I forgot that I paused the recording. I ended up rejecting this hypothesis because the significance level or the p-value in percentages is smaller than my significance level, which means the coefficient is, Now I'm all messed up. All right. Redo. Take two. All right. So I rejected this hypothesis because the p-value is smaller than the significance level, means the t-stat is huge. And when the t-stat is huge, the difference between the estimated coefficient and 0 is highly significant. On the next hypothesis, I couldn't reject that at 1% because its p-value in percentages is 8.21%, and that's bigger than my 1% significance level. So that means the t-stat is small, which implies that the difference between customer income coefficient minus 0, it means that difference is insignificant. That's why we couldn't reject that null hypothesis. We're concluding that this is 0, likely 0. We're concluding that that is likely positive and not equal to 0. I mean, sorry, negative and not equal to 0. Now this one's the model hypothesis, where we're testing that the price coefficient is equal to 0 and the income coefficient is equal to 0, right? We rejected that because the F statistic p-value is tiny. In percentages, it's 0.05% in my model. My significance level is 1%. So that means the F statistic is massive, which means the collective difference between this and 0 and this is 0, that collective difference, those collective differences are significant. And then this right here, we conclude from this right here, we interpret this as what? The price of lobster has a significant negative effect on quantity of lobster. This is negative, and the p-value is really, really small. That's why we say a significant negative effect on the quantity of lobster. In terms of customer income, the coefficient is positive, but the p-value is bigger than the significance level of 1%. So we're going to say this, in my model, I'm going to say that this has a positive insignificant effect on quantity of lobster sold. And then the model is the quantity of lobster equal to the intercept plus the slope of the price of lobster times the price of lobster plus the slope of customer income times customer income. So this is the model. And this last hypothesis says that the model is significant, right? Now I'm going to put you on pause and I'm going to fix the error in the problem. Okay, if you reload it, everybody, if you reload it, you'll see the prices pop up. You'll see the price of lobster pop up, and you see the average customer income pop up. Okay. All right, so if Blue Lobster Bar and Grill charges a price of 37, 37 is my average rounded at 0 decimal places. See that? So the mean price of lobster is 37.24 in my model, but I rounded it to 0 decimal places down here, right? And then my average customer income is $6,342 to 0 decimal places, but the 2 decimal places is $6,341.75, right? So I'm just rounding these to 0 decimal places, the averages, right? So what we're going to do down here is we're going to do this. I'm going to put the averages. I'm going to put the averages right here, right? So lobster price average is 37. customer income, I'm going to grab it from here, see? 6342. Right? So those are my averages, right? And this is my predicted value, my predicted quantity, right? My predicted quantity. Okay. So the way I get my predicted quantity is I'm going to use something called sum product. I mean, I could do it this way. I did this earlier, right? I'm going to take the coefficient or the intercept, right? What am I going to add to that? I'm going to take the average price of lobster and I'm going to multiply it by the coefficient of lobster. See that? Then I'm going to add to that my average customer income plus the slope for customer income. You see that? And I get, whoops, this should be a multiplication here. Yeah, there we go. So I have my intercept right here plus my average lobster price to 0 decimal places times the slope of lobster price plus my average customer income rounded to 0 decimal places times my customer income. And I get 117.46, right? Another way to do that is to do this. You can use equal sum product. My first array are these three numbers. My second array are these three cells. There's nothing in that cell right there. See that? That's another way to do it. You get the same number. Whoop, should have the same number. That's weird. Take the product, add it to these two, plus those two. That's weird. That is really weird. It should be the same number.
It's not working also for me.
That is really strange. That is really weird. It should work. I've never seen this before. This should work. Weird. All right, we'll just delete it. I'll have to come back and figure out why that doesn't work. It should work. Because all we're doing is we're taking the products. Oh, yeah, that's why. We need to make that 1.
Okay.
Yeah, we make that 1. There we go. Duh. I was multiplying it by 0. So what we're doing here is we're multiplying in this last column here. We're multiplying this by 1. We're adding that to this times 37. And we're adding that to this times 6342. And we get the same thing. So that's my predicted quantity if my income is average and my customer income is average, right?
Yeah, let me see.
Yeah. Now, if Blue Lobster Bar and Grill had changed, if Blue Lobster Bar and Grill had changed its price to 38 instead, had charged a price of, yeah, there we go, charged. I've been up too much today. I didn't get sleep till like 2 o'clock in the morning. I got up at 6. Plumbing issues. So I can't read what I'm writing here. I can't read what I wrote. If Blue Oyster or Blue Lobster Bar and Grill had charged, that font is really weird. If Blue Lobster Bar and Grill had charged a price of 38 instead, all we got to do is change this to 38, right?
Mhm.
Change it to 38.
I see.
And it goes down, right? So if the price goes up, what does our predicted quantity do? Holding income constant, right? Now, here's something to note, right? Here's something to note. I'm going to copy this and paste it as a value, right? I'm going to change this back to 37, right? What's the difference between these two? $1.95. Oh, that's the coefficient of lobster price, right? You see that? You see that right there?
Yeah.
If I increase my average price by $1, quantity is expected to fall by 1.95, right? So that is not coincidence, right? So this is assuming the price is 38. This is assuming the price is 37, right? And so if I increase the price by $1, right, what happens to my expected quantity? It falls by 1.95, right? That's the amount of the lobster price slope. Right? That's the slope of the lobster price. All right. That's the question. That's question 1, right? We'll take a break. And during the break, Matthew, were you able to, let me turn off. I'm going to close out Zoom and restart it so I can process the video. Okay.
Okay.
I'm going to reopen Zoom.